This video is on the properties of graphs of quadratic expressions, specifically the vertex form y equals a times the quantity x minus h quantity squared plus k. In the vertex form, we can see transformations of translations and scale changes being applied. With h and k, you will see the graph shift both horizontally and vertically respectively. And by multiplying a to the quantity, we will see a vertical scale change being applied as well. Now, in advanced algebra, we used to refer to the vertical scale change factor as the letter b. We're going to change it to the letter a for a couple of reasons. One, it's a little bit more traditional, and more importantly, two, the value of a will now be the exact same value of a that was also used in the standard form. So literally, ax squared and a times the quantity x minus h quantity squared can share the same property. In this case, let's say the direction of opening. As long as a is positive, the direction of opening of the parabola will go up. If a is negative, the direction of the opening will go down. We can also apply essentially knowing that the narrower the graph is because a is much farther out. And we can also see that the graph will become wider as a gets closer and closer to 0. Let's go reset this back to a equals 1. We won't worry so much about the direction of opening at this time. And let's focus now on really what h and k does. So first off, when we make h negative, you will see that the graph is shifting all the coordinates to the left. If you make a positive, you will notice that it's shifting all the coordinates of the original parabola to the right. If we would move k down, it's because k is negative. And so the bigger the negative, the farther the graph is being shifted down. If you make k positive, you will see now that the graph is being shifted upward. And these are all translations. More importantly, as we adjust h and k, we are adjusting the vertex of this particular parabola. For instance, if I would make h equal to 1, and I would make k equal to 2, you will see that my vertex now is listed as 1, 2. That is because the vertex always has the coordinates h, k. Let's highlight that right there so you can see that. Okay? So, when I look at this expression, this vertex form, I have to remember that it's x minus h. So I look at the x, I look at the minus, I ignore those, and I see that my h has a value of 1. I see also that my k has a value of positive 2. Therefore, my vertex would be at 1, 2. If I were to happen to move, let's say, h over to, let's say, negative 3, it might show up as x plus 3 in the vertex form. That's going to be the quantity squared. But I have to remember that's x minus my h. So that really is x minus a negative 3. That value right there. And that's why my vertex is a negative 3. My k still will be at 2 because I have not shifted that. And you'll notice that my vertex is at negative 3, 2. Again, it doesn't matter what the value of a is because the vertex itself is always staying put. Let's move on to another property that we can get from the vertex, known as the axis of symmetry. We know that all parabolas have line symmetry. We should also remember that those parabolas have line symmetry through the vertex. So, if I was to be asked to write an equation for the axis of symmetry, you have to remember that you have to write an equation. So you can't just say the value of negative 3. You need to say x equals the h coordinate. X equals negative 3. Remember, the axis of symmetry is an equation, and it requires you to write x equals before you give me the value of h. Again, if I shift the graph over, let's shift it all the way over to 5 units, and let's move k down. It really doesn't matter what I make my value of k. My axis of symmetry is staying put. Just like it doesn't matter if I switch the a. It all comes down to the value of h. Hence, the axis of symmetry is x equals h. So, if you know what your vertex is, then just write x equals and take the h coordinate. Now the vertex also can tell me what is the min and max of a graph. Basically, whatever my y-coordinate of my vertex is, this will determine what the min and max is. The problem is I have to know if it's a min or a max. That is all going to come down to the direction of the opening. Again, if my A is positive, the parabola is going up, and therefore this would be, the vertex would be the minimum point, or the minimum, its y-coordinate would be the minimum height of all possible heights. If I, on the other hand, shifted the parabola so it went in a downward direction, what was once the minimum now has become the maximum. Let's move k to, let's say, -2. Now I could say that this is the largest height that this graph will ever reach. And when you start talking about the heights of graphs, you are talking about the domain and range. All parabolas have a domain of all reals, so it's not going to make a difference if you shift it left or right, or up and down, or upwards or downwards. You will notice that as long as it is a parabola, the domain is going to be all reals. More importantly, look at the k value and notice that's going to determine where the min and max is. Since my k right now is 0, which is easily determined right here outside, I know, and my parabola is going up, I know this is the minimum. Because it's the minimum, I can say that all ranges will be the values of y greater than or equal to 0. If, on the other hand, the parabola was going down and that min now became a maximum of 0, then my range would be all values of y less than or equal to 0. Again, I could shift the graph left or right. It really won't make a difference what my range is or my min and max is. But on the other hand, let's say I go to 3. My maximum is 3 because I'm going in the downward direction because my A is negative. Therefore, my range is going to be all y's less than or equal to 3. If I make my A positive, the vertex hasn't moved, so now the vertex just means it's going to be the minimum height, which is 3, and my range will now be all values of y values greater than or equal to 3. So let's recap one more time all the properties of the vertex form. First off, the A is the same A in both the vertex form and the standard form. So it can tell you what direction going up and down for the parabola's opening. It can also tell you the width. The H and K is critical because it tells you so many other properties. The most important one being the vertex. Again, as H is a positive number, you're shifting the graph to the right. If H is a negative number, you're shifting the graph to the left, and you're also doing that to the vertex. If you make K positive, you're going to be shifting the graph upward. If you make K more negative, it is going to go downward. Again, whatever the H and K coordinates are is going to be the coordinates for your vertex. In the case of the vertex and the x coordinate of the vertex, it will also be part of the equation x equals h, or in this case x equals -2.4 for your axis of symmetry. The y coordinate of the vertex is used to determine your min and max and also your range. If the parabola is going up, your min is you're going to have a minimum value, and the range will be y greater than or equal to that minimum y coordinate. If your A is negative, now that y coordinate is going to be used as its maximum height, which means all the range will be y is less than or equal to that y coordinate. And this concludes the properties of graphs of quadratic expressions, specifically for vertex form.